Hello all, let's learn regarding the lacrimal apparatus. This lacrimal apparatus is a system which includes the production of the lacrimal fluid, which is tear, the moisturizing of the eyeball by making a film it over the surface of the eye, and the drainage of this lacrimal fluid. So here in this figure, this is the lacrimal gland. These are the ducts of the lacrimal gland. Both these structures are responsible for the production of the lacrimal fluid and transportation of this lacrimal fluid to the conjunctival sac. So this is the conjunctival sac, and here this is the lacrimal canaliculi. This is lacrimal sac, and this is nasolacrimal duct. And these three structures, they are responsible for the drainage of the lacrimal fluid. So this is the basic information regarding the lacrimal apparatus. Now let's see the path of the lacrimal fluid from the lacrimal gland to the nasolacrimal duct. So the lacrimal fluid is going to be secreted by this lacrimal gland, and it will be transported to the conjunctival sac via these ducts of the lacrimal gland. And from the conjunctival sac, the fluid will ultimately goes to the lacrimal canaliculi, and through the canaliculi, both these canaliculi, this lacrimal fluid will reach up to the lacrimal sac, and through the lacrimal sac, the fluid will drain ultimately into the nose via this nasolacrimal duct, which open into the inferior meatus of the nose. Now let's see the lacrimal gland. This lacrimal gland having two parts. One is the larger part, and that is called as the orbital part, and one smaller part which is called the palpebral part. The levator palpebrae superioris muscle, it is going to separate both this part. This orbital part, it is almond shaped, situated in the anterolateral part of the roof of the orbit. Somewhere here, this is the orbit, and here the orbital part lies. So this is the superolateral part of the roof of the orbit, where actually this lacrimal gland lies. When we see the relation of this orbital part, inferiorly it is connected with the fibrous septum through the levator palpebrae superioris. In front, it is extend up to the orbital septum, which is going to form the part of the eyelid, and behind it is continuous with the orbital fat. When we see this palpebral part, it is around 1/3 of the orbital part, and it extends into the lateral part of the upper eyelid below the levator palpebrae superioris muscle, and it reaches up to the superior fornix of the conjunctiva. This lacrimal gland having 12 lacrimal ducts. Out of them, 4 to 5 are from this orbital part, and 6 to 8 are from the palpebral part. For simplicity, here we shown only one duct from the orbital part and 3 ducts from the palpebral part, but actually there are 12 number of the ducts. Out of them, 4 to 5 are from the orbital part and 6 to 8 are from the palpebral part. All these ducts, they are going to open into the lateral part of the superior fornix of the conjunctiva after passing through the palpebral part. So clinically, the removal of this palpebral part, it is actually equivalent to the removal of the whole gland, because all the ducts, they are going to pass through this palpebral part of the lacrimal gland. Some accessory lacrimal glands are also present, and they are present within both the eyelids, but more in the upper eyelid at the fornix. And this accessory lacrimal glands, these are called as the accessory lacrimal glands of Cruz, and this is the reason why the removal of the whole lacrimal gland, it will not lead to the dryness of the eye, because the moistening will be provided by these accessory lacrimal glands of Kruse. When we see the structure of this lacrimal gland, it is compound tubulo-alveolar gland, which is predominantly serous in nature. These alveoli, they are lined with the simple columnar epithelium resting on the basement membrane and having the myoepithelial cells in between the basement membrane and the surface epithelium. There are basically two types of the cells are observed in this epithelial lining of this gland, and these are named as K cells, which are responsible for the secretion of the mucus, and predominantly G cells, which are responsible for the serous secretion. The secretion of this gland, it is the tear, and which is actually the alkaline in nature and having various salts and enzyme, that is the lysosome within it, which is actually bactericidal. Probably less than 1 ml is secreted per day. From this secretion of this lacrimal fluid, the half of the fluid it gets evaporated and the rest drain into the lacrimal sac. The excessive secretion of this lacrimal fluid that will roll down as tear. This fluid, that is tear, it is responsible for flushing the conjunctival sac and keep the cornea moist and transparent. This fluid is also responsible for providing the nourishment to the cornea. It is bactericidal also, and it expresses the emotion with the outbreaks of the tear. When we see the arterial supply to this lacrimal gland, it is supplied by the lacrimal branch of the ophthalmic artery. When we talk about the secretomotor fiber to this gland, it is via the parasympathetic fibers. These periganglionic parasympathetic fibers, they are going to pass along with the facial nerve, and this facial nerve will give one branch, that is the greater petrosal nerve, and via this greater petrosal nerve it reaches up to the pterygopalatine ganglion, and within it these secretomotor fibers are going to relay. Then the postganglionic fibers will passes and it will join the maxillary nerve, and this maxillary nerve gives one zygomatic branch, and this zygomatic branch will ultimately joins the lacrimal nerve, which is going to supply the lacrimal gland. Now let's see some brief detail regarding the conjunctival sac. Here in this figure, this is the area for the conjunctival sac, which is responsible for the moisturization of the eyelid with the lacrimal fluid, and then it will carry the lacrimal fluid from lateral side to the medial side to ultimately help it to drain into the nasal cavity. So for the better understanding of this conjunctival sac, we have to take a sagittal section and we have to see it from the side to view this figure. And here this is the upper eyelid and this one is the lower eyelid, and here this is the eyeball with the sclera, and here this is the cornea. This conjunctiva, it is nothing but it is the mucous membrane which is transparent in nature, and it is going to line this inner surface of the eyelids as well as the outer surface of the sclera as well as the cornea. And both these conjunctival folds, they are named according to their lining property. And this conjunctival mucous membrane lining the inner aspect of the eyelid, it is called as the palpebral part of the conjunctiva, while the conjunctival mucous membrane going to cover the sclera and the cornea, and this conjunctival portion, it is called as the ocular conjunctiva. The other name of this ocular conjunctiva is the bulbar conjunctiva. So this palpebral conjunctiva as well as the bulbar conjunctiva, they are continuous with each other at the upper margin as well as at the lower margin, and these two are called as fornixes of the conjunctival sac. This palpebral conjunctiva, it is the opaque and it is highly vascular in nature, which is going to line the inner aspect of the eyelid and continuous at the margin with the skin of the eyelids. While this ocular conjunctiva or the bulbar conjunctiva, it is a transparent because it has to cover the cornea particularly to provide the proper vision to the eyeball. And this ocular conjunctiva, it is transparent in nature and it is the mucous fold which is firmly adherent to the cornea but loosely adherent to the sclera to provide the proper movement of the eyeball. The conjunctiva related to the upper eyelid, that is the palpebral conjunctiva of upper eyelid, and the ocular conjunctiva concerned with the upper eyelid, that is supplied by ophthalmic division of the trigeminal nerve, while the conjunctiva concerned with the lower eyelids supplied by the maxillary division of the trigeminal nerve. Now let's see the lacrimal canaliculi. Here this is the area for the lacrimal canaliculi. It is one in each eyelid and it is around 10 mm in length. When we zoom it and try to see the structure, it opens with the conjunctival sac through this opening, and this opening, it is called as the lacrimal punctum. The superior canaliculi, it first passes upward and then it takes a bend and passes downward and medially to reach into the lacrimal sac. While the lower canaliculi, it first passes downward and then it passes upward and medially to connect with the lacrimal sac. This bending at both the canaliculi represent one dilated portion, and that is called as the ampulla of the canaliculi. Out of this 10 mm length, the portion before the ampulla, it is of 2 mm, while the portion of the canaliculi after the ampulla till it open into the lacrimal sac, that is the 8 mm. When we see the structure of the canaliculi from inside to outside, it is lined by the stratified squamous epithelium, and just outside to this stratified squamous epithelium there will be some elastic tissue layer which is responsible for the dilatation of this canaliculi, and just outside this elastic tissue layer some striated muscle fibers are present, and these striated muscle fibers, they are from the orbicularis oculi and which act as the sphincter at the canaliculi.